So we're factoring x squared plus 4x minus 5. When you're factoring these, you want to make sure that there's 3 terms, 1, 2, 3, and you want that first number to be a 1. So that is a 1x squared. So when you have 1x squared and you have 3 terms, the process, or one way, is to make an x, and you put the constant on top, and then you put the middle term on bottom, and what you're trying to find 2 numbers that multiply to -5 but add to a 4. So I'm going to think about -5, and I know that 1 and -5 multiply to -5, and then I also know that -1 times +5 is -5, and those are the only 2 combinations. 1 times -5 is -5, and then -1 times +5 is -5. But when you add these, if you add 1 plus -5, you get -4. When you add -1 plus 5, you get +4. And that's what you want. You want them to add to +4. So you'll take these numbers, you'll put those on the side, and then you'll write these as what's called linear factors. So our variable is x, so we'll go x, and then we'll do -1, and then we'll do x with a +5. So these are what we call linear factors. If I were to distribute this out and go x times x, x times 5, -1 times x, -1 times 5, I would get back the quadratic in standard form. Okay. Yeah, number 7. Number 7, I look at this and I say there's 1, 2, 3 terms. However, the term in front is a -1. When you're factoring, you never want a negative out front. Lucky for us, there's an easy fix to get rid of a negative out front. You just factor it out. When you factor out a negative, all it does is changes the signs. It negates everything. So that's going to go from to positive, that to negative, that to positive. So now I look at this and I go, all right, I got 1, 2, 3 terms, so it's a trinomial, and now a is 1. Now the -1 is important. That's what flips the parabola upside down, but it doesn't mess with the solutions. So I do the same thing as before. I ask myself, what multiplies to 72? But adds to -17. Now, if you're good at multiplication tables, this doesn't take very long. Otherwise, it may take some time. The thing I'm noticing is to multiply to positive but add to negative, they're going to have to both be negative. So maybe -1 and -72. If you add those, you get -73, not even close. So let's go to -2. -2 and -36. You add those, you get -38. Does 3 go into 72? Let me think. Yes, it does. Negative 3 and negative 24. You add those, you get negative 27. We're getting close. And then 4 goes into it, so let's try negative 4, which is 18. You add those, you get negative 22. 5 does not go into 72. 6. 6 would be negative 6 and negative 12. I'm getting pretty close. That's negative 18. 7 does not. 8, negative 8 and negative 9. There we go. It took me a while, but I finally found it. The combination that adds to negative 17 is this one. So I put negative 8, negative 9. Negative 8 times negative 9 is positive 72. Negative 8 plus negative 9 is negative 17. In this problem, we're now dealing with y as our variable. So I'll put y minus 8. I'll put y minus 9. And then I'll pull down my negative. So looking at this, I have just now factored this into this. To check your work, you could distribute this out. I'll show you a different way. You could actually use Desmos to check your work, and I will show you that. So when you're typing this into Desmos, Desmos is not smart enough to deal with y, so we're going to have to type it in with x's. So there's the first graph. That's what we call standard form. And then I think factored form is this, and I'm going to type it in with x's instead. And you can see they are the same thing. They're on top of each other. Therefore, I know that they are the same thing, and I know what's kind of interesting, if you really look at this, this is factored form. It tells you the x-intercepts. The x-intercepts are 8 and 9. And if we zoom in, we see that the x-intercepts are 8 and 9. That's one thing that's useful about factored form. Okay, number 13. Again, I'm going to count. I have 1, 2, 3 terms. It's a trinomial. However, the first term is negative. We don't like that, so we're going to get rid of the negative. And also we have a 3. So I am going to not only take out a negative, I am going to take out a 3, because 3 goes into 3, 3 goes into 3, 3 goes into 60. 3 times 20 is 60. So what I'm going to do first is I'm going to factor out a negative 3. You do not always factor out this number. It just so happens that that's how it works on this problem. So I'm going to factor out negative 3. The negative is going to change all the signs. So it's going to change this to positive, positive, negative. And then negative 3 times what is negative 3x squared. That would just be x squared. Negative 3 times what is negative 3x. That would be x. And negative 3 times what is 60? That'd be negative 20. If I just confused you, all I did was I divided negative 3 by negative 3 and I got 1. I divided negative 3 by negative 3 and I got 1. I divided 60 by negative 3 and I got negative 20. And to show that I divided them all by negative 3, you put that outside to show that's important for the graph. From there, I'm looking for two numbers that multiply to negative 20. But add to 1. That's a 1x. So it needs to multiply, and I'll even put that here just so you remember, multiply to negative 20, but add to 1. So thinking about negative 20, that could be 1 times negative 20. It could be negative 1 times 20. Because a negative times a positive is negative. Adding those, I get negative 19. Here I get positive 19. I could try 2 and negative 10. That'd be negative 8. And then I could do negative 2 positive 10 would be positive 8. Okay, we're getting close. 3 does not go into 20. 4, I could do 4 times negative 5. 4 plus negative 5 is negative 1. I'm getting close. And then I could do negative 4 times positive 5. And there we go. Negative 4 times positive 5 is what we're looking for. This adds up to 1, which is what we want. The rest didn't work. From there, I'll put negative 4 and positive 5. So negative 4 times positive 5 is negative 20. Negative 4 plus 5 is 1. You don't have to do this work on the side if you're really good at multiplication. So putting all that together, I would have x minus 4, x plus 5 with the negative 3 out front. So it'd be negative 3 x minus 4, and then x plus 5. And then I'm going to go ahead and double check my work. I could distribute all this out, or I could go and type it into Desmos and make sure they are. So typing these in, the first one was negative 3x squared, which is going to flip it over, zoom out. That's what the negative does. It flips the parabola over. And then minus 3x. And then a y-intercept of 60, about to move way up. So if I go way up here, the y-intercept is 60. And then the other one, the factored form, I think the x-intercepts are 4 and negative 5. So looking at this 4 and negative 5, I see that they are the same thing. And looking down here, the x-intercepts are negative 5, positive 4. Okay? So they are the same thing, and I know that I did this correctly.